All right. So the last little bit for integration, just like your basic, practice with integration before we move to applications, do deal with your trig functions. You can't forget about those. And here they are. The integration for sine x dx is negative cosine x plus c. And for cosine, it's just regular sine x plus c. Now, to my understanding, those first two are in your reference booklet, so you don't have to worry about memorizing them. However, the last two that are in pink, those aren't in the reference sheet, and you will need to remember those.
Is there like an equals?
Yeah. Okay, now what you should notice is that, the last two, the two that I'm like, you're going to need to remember because it's not in your reference booklet, is it kind of has that linear function part in it, like the ones that used to be on the board, okay? Very similar. You still have your 1 over a, the derivative the antiderivative of sine is cosine, or negative cosine, and then ax plus b, plus c, and then the same to 1 over a. But here are going to be your main ones that you're going to be dealing with, okay? We're going to look at some examples on the next page that we'll do together, and then you'll do some on your own. And we'll check hopefully together. So the same, with your power rule, with your substitution method, they still can be applied here. Constant rule still apply here, okay? So the first one, we have the integral of 3 sine x dx. Well, that 3, is nothing but a constant that we can do what to? Take it out. And then this is just very simple. The integral of sine x dx is negative cosine x. So this becomes a negative 3 cosine x plus c. Alright? Please make sure you put the negative on this side of the 3, because otherwise your grader might think you're saying 3 minus cosine x, okay? So actually make sure you do that. That's the material. We'll go across to the integral of cosine of 4x minus 6 dx. Okay, well that 4x minus 6 is that linear function, okay? So if you recall from the formula for cosine, it's going to be 1 over a. What's a? So it's going to be 1 over 4 sine and then plus c. And that's it. That's as far as you can go. All right? If anything, this would be like your chain rule of integration, like when you're dealing with your linear functions. Because if you think about it, it's kind of like you're taking the inside. It's not really the integral, but it's something similar, if anything. All right, the next one. This one. What do you think? I can't use constant rule here. Do I have a linear function? No. Substitution. Because I basically have this function e to the x, and then I have sine e to the x. So what am I going to make u? It's going to be e to the x. Because what's the derivative of e to the x? And if you look at your problem, here's e to the x that I'm using, and then here's the derivative, e to the x dx. Okay? So this is the e to the x that I made u, and then here's the derivative. That's underlined, right? So when I go to substitute it in, I'm going to have the sine of u, and then e to the x dx is going to be replaced with a du. Did everybody see that? What's the integral of sine u? negative cosine u plus c. But I can't leave that u there, I have to replace it with e to the x, which was originally my u. Okay. Questions? And the last one. What do you think? Substitution? What am I making u? 3x to the 4th. So du is going to be what? 12x to the 3rd dx. I have to divide by 12 because I do not have a 12x cubed, I just have an x cubed. So it's going to be 1/12 du equals x cubed dx. So when I substitute, this becomes cosine of u, and then I have a 1/12 du that's going to replace x cubed dx. I can take out the 1/12. And the antiderivative of cosine u is what? Sine u plus c. But I am not going to leave that u in there. It's going to be replaced with a 3x to the 4th plus c. Okay? So same rules still apply with your trig functions. Constant rule, substitution. They even have their own linear factor rules or linear function rules. Okay? So we'll look at a couple of examples from your homework. Probably don't get to get to like 1, maybe 2. Okay? Alright, so what am I going to use? Substitution. What am I going to make u? Tangent what? Tangent 3x, yes, because you got the exponent there. And yeah, I would say the rule of thumb is make that exponent your u, okay? Now, you got to go back, you got to think, okay, so what is the derivative of tangent? Was that one that was on my reference sheet? That is, that's the identity for tangent. It's 1 over cosine squared x. But it's not an x here, it's a 3x. So yes, the derivative of tangent x is just cosine squared x, but since we have a 3, this becomes a 3x dx. So even though, yeah, it might have looked a little complicated, actually, not too bad. So when I go back and substitute it back in, it's going to be e to the u, and then that 1 over cosine squared 3x dx is going to be replaced with a du. And so what's the integral of e to the u? E to the u plus c. But I can't leave that u in there, so I'm going to replace it with a what? A tangent 3x plus c. Okay, this was number 7. You want me to do one more?
Number 6.
Or 6.
No.
No, is it not 6? It's pretty simple.
Yeah.
Well.
Twelve. 8.
No.
What do you think is the hard one?
3.
What do I think is a hard one?
Yeah.
I'm so recording this. Realize this.